Our second lesson from our circles chapter is going to talk about angles and arcs. So there's two main types of angles that we're going to discuss, the inscribed angle and the central angle. An inscribed angle is an angle whose vertex is on the circle and it is formed by two chords. So here's the example for that one. You'll notice the vertex is on the circle and there's a chord and another chord. So this highlighted angle in here would be an inscribed angle. The second type of angle is a central angle. A central angle is an angle whose vertex is at the center of the circle and it is formed by two radii. So here's an example of that. This dark area is the central angle. This vertex is right on the center of the circle. We have a radius there and a radius there, so the two radii are what forms our central angle. When the chords or radii that make the angle touch the circle, the curved portion of the circle between the points is called an arc. So here are two examples of that. Here's an inscribed angle. So where it touches the circle out here at the ends of the angle, not the angle here, but the ends of it, the curved portion between those two endpoints is the arc that it makes. And here we have a central angle. And so if I follow those radii out, the points where they touch on the circle, that curved portion of the circle between the endpoints is called an arc. There are three major types, or three classifications that we can give to arcs: minor, semicircle, and major. So minor is going to measure less than 90 degrees, not 90, 180, sorry. I was thinking of something else. 180 degrees. A semicircle measures exactly 180 degrees. It's halfway around the circle. And then a major is going to measure more than 180 degrees. So the 180 will be kind of the defining difference between what type of arc we have. So I want to identify some of them over here. Let's talk about the semicircle first. So the semicircle is the half of a circle. So I have a diameter here in EG. So from E through F and on to G, so arc E, F, G, and we use like a curved symbol over those letters. That would be a semicircle. I could also go the other direction, from E through H and finishing at G. That would be another semicircle. So EHG would be another semicircle. Minor arcs are the ones that are going to measure less than that semicircle. In this case, there are several of them. E to F, just that piece right there. So when we name a minor arc, we just use two letters. That's our indication. Go the short way between these two letters. From F to G would be another minor arc. From G to H, and from H to E would be another minor arc. Noticing these are all less than a half of a turn, or less than half of a circle. Now your major arcs are also going to use three letters because they're going to tell you, excuse me, to go the long way. So it's going to give you the starting point, a point to go through, and then an end point, kind of like these do. The EFG tells us to go from E through F and end at G. So if I wanted to name a major arc, maybe I could say like E through F and end at H. E through F and end at H. That would be a major. It's more, I kind of do this, that's more than halfway around the circle. G is halfway, but if I keep going, that would be a major arc going more than halfway around the circle. I could do H, E, F. That would also be a major arc. So starting here, going through E, and ending at F. If I kind of do a little line like that, we could see where the semicircle line would be. We know we've went over that, so that would be another major arc. I'm not going to name all of them because there's a lot of major arcs there. Just want to make sure you understand that you're going to use a difference when you name them: 2 letters for a minor, 3 letters for the semicircle, and for the majors. So you're telling what point to go through to get between those two endpoints. All right. The arcs are related to the angle that creates them. A central angle is equal to its arc, so they have the same exact measure, whereas an inscribed angle is equal to half of its arc measure. So let's look here. We have a central angle at point P. This measures 110 degrees, so if I follow that side out to A and this side out to B, this is the arc it creates, arc AB, and that will also measure 110 degrees because central angles are equal to their arcs. This one is an inscribed angle here at point C, so if I follow those sides out, I get D. Follow this side out, I get E. So from D to E, the arc that it creates, the angle is half the arc. So if the angle is 40, that means the arc has to be 80 degrees. The angle is half the arc. So you got to think about that relationship. The arc should be bigger than the angle. And then I have one that has the two of them together. What we have written down is this 25 degrees, which is down on the inscribed angle. So if I follow the inscribed angle sides out, I go from F to H and from F to I. So HI is the angle, or sorry, the arc that angle makes, and the arc is twice the angle because it should be bigger. The angle is half the arc, so the arc should be 50. So arc HI is 50 degrees. And then it asks the second question, what's the measure of angle HGI? So HGI, that's this angle right here. And if I follow those sides out, I get H and I, so it makes the exact same arc, but a central angle and its arc are equal. So if the arc is 50, the central angle will be 50. So here we would have 50 degrees for the measure of angle HGI. So I have 3 examples for us to kind of quickly go through, make sure we're seeing the different types of angles and what they would mean and how to use those with the semicircles and that type of thing. So here the only measure we are given is this arc, which is on arc RS. If I follow those back, they give me this angle right here. And I know that would be 60 degrees as well, okay, because central angles and their arcs are congruent. But more importantly, I see RCT is a diameter. So a diameter means a semicircle. So from R through S and ending at T, that whole thing has to be 180 degrees because that's a semicircle. So if R to S is 60, then 180 minus 60 would give me 120 degrees right here from S to T. And that is the measure, or the arc, that is made by this angle that we're being asked about. We're being asked about the measure of that angle, and if I follow that angle out, it makes T, S, this arc. So if the arc is 120, then that angle will be 120. So the measure of angle TCS is 120 degrees. Then we have this one right here where we have an inscribed angle given to us. This inscribed angle right here is 95 degrees. So I know that an inscribed angle is half its arc. So if I take 95 and double that, I would get 190, I believe. I am going to grab my daughter's calculator and just double check that because I would hate to be wrong in writing that out. Yes, okay. So now a full circle is a 360. What I'm being asked about is from A to B right here, this arc, or B to A, whichever way you say it. So a full circle would be 360. So if I start with 360, subtract out the 190, and then subtract out this 80, which already has been told to me down there, then the remaining amount should be the amount of the angle way over here. Okay, so I'm going to use the calculator so I don't miscalculate. I would hate to do that on the video and have some of you thinking, well, where did she get that number? And I get 90 when I do that. So that means this arc over here would be 90 degrees. So the measure of arc AB is 90 degrees. And then we have our last example, and this has some inscribed angles in it as well. One of them is the angle we're being asked to find. The inscribed angle that's being questioned here, if I follow those sides out, I get W and Z. So it would be really helpful to me if I knew this arc, because I know that the angle would be half of that. Well, I can find that arc because I have another inscribed angle over here, so if I follow that out, I get X and Y. So this arc for XY will be related to this angle. The angle is half the arc. So if the angle is 40, then the arc is 80. So now I know all the way around the circle would help me figure out what this arc is right here. So we'll start with our 360. We'll subtract out the 85 that was written right here, the 80 we calculated here, and the 90 that's written over there, and that should tell us what WZ is. So again, I'm going to use the calculator just because I don't want to mess up and have some of you wondering where I got some crazy number. So I subtract those and I get 105. So this arc is 105 degrees. And therefore, I should be able to find the measure of the angle. So the measure of angle WYZ the angle is half the arc, so I need half of 105. That would be 52.5 degrees. So keep in mind your central angle will be equal to the arc. The inscribed angle will be half of the arc. Utilize that relationship today as you're checking out your diagrams. And as always, let me know if you have any questions.